This wide panorama shows Curiosity rover at the rock nest site where the rover scooped up samples of wind-blown dust and sand. The image is a scaled-down version of a full circle view which combined nearly 900 images taken by the rover using 3 different cameras over a course of 7 days. The view therefore shows illumination effects from variations in the time of day for pieces of the mosaic, and also shows variations in the clarity of the atmosphere due to variable dustiness during the month while the images were acquired. This delta called Ebbswald is located in a crater northeast of Holden crater. The image covers an area of about 1.9 by 1.9 miles and offers a higher resolution view of a portion of the fossil delta than any seen earlier. At the left of the frame, the image includes the north end of a looping inverted meandering channel. The delta provides the first clear smoking gun evidence that some valleys on Mars experienced persistent flow of liquid with the physical properties of water over an extended period of time, as do rivers on Earth. In addition, because the delta today is lithified, that is hardened to form rock, it provided the first unambiguous evidence that some Martian sedimentary rocks were deposited in a liquid, presumably water environment. The presence of meandering channels, a cut-off meander and crisscrossing channels at different elevations, one above the other, provide the clear geologic evidence for these interpretations. After the sediments were deposited to form the delta, the material was further buried by other materials, probably sediments that are no longer present. The entire package of buried material became cemented and then hardened to form rock. Later, erosive processes such as wind stripped away the overlying rock, re-exposing the delta. now preserved essentially as a fossil. The former floors of channels in the delta became inverted to form ridges by erosion. Channels can be inverted by erosion on both Earth and Mars. Usually this happens when the channel floor or the material filling the channel is harder to erode than the surrounding material into which the channel was cut. In some cases, the channels on Earth and Mars have been filled by lava to make them more resistant to erosion. In the case of Eberswald, there are no lava flows. Instead, the channel floors may have been rendered resistant to erosion either by being better cemented than the surrounding material or composed of coarser-grained sediment such as sand and gravel as opposed to silt or both. This view shows a dark sand dune in the middle distance, which were the first in-place study of an active sand dune anywhere other than Earth by a Mars rover. The dunes are part of a band of dunes called Bagnall Dunes along the northwestern edge of Mount Sharp. The dune field is evident as a dark band in orbital images of the area inside Gale crater where Curiosity has been active since landing in 2012. Dunes here are larger than wind-blown ripples of sand or dust that Curiosity and other rovers have visited previously. One dune that Curiosity investigated is as tall as a two-story building and as broad as a football field. Ripples on the surface of these Martian dunes are also larger than ripples on the surfaces of sand dunes on Earth. This image shows a rock on the southwestern slopes of Endurance Crater. Scientists believe the rock's fractures, which divide the surface into polygons, may have been formed by one of several processes. They may have been caused by the impact that created Endurance Crater, or they might have arisen when water left over from the rock's formation dried up. A third possibility is that much later, after the rock was formed and after the crater was created, the rock became wet once again, then dried up and developed cracks. Tests have also shown that rocks located deeper into Endurance crater are chemically altered to a greater degree than rocks located higher up. This chemical alteration is believed to have resulted from exposure to water. Martian clouds, both the day and night variety, resemble the wispy and high-flying cirrus clouds on Earth, except they are thicker and found at more variable heights. Previous studies have detected daytime clouds on Mars as high as 62 miles above the surface, making them the highest flying clouds ever detected on any planet. Though much less substantial than earthly clouds, Martian clouds play a big role in the planet's climate as they help to keep the planet's surface warm after sunset as the temperature drops. This view of the floor of Jezero crater was taken by one of the NavCam imagers aboard NASA's Perseverance Mars rover. The rover's tracks can be seen disappearing into the distance. The flat-topped hill called Kodiak, a remnant of Jezero crater's river delta, is in the upper right of the image, about 0.6 miles away. A thin layer of water frost is visible here on the ground around NASA's Mars rover in the early morning hours on Mars. When this image was taken, the sun was about 22 degrees above the horizon, enhancing the detail of the polygons, troughs, and rocks around the rover. The frost then begins to disappear shortly after as the sun rises. Small impact craters usually have simple bowl shapes. However, when the target material has different layers of different strength, then more complicated crater shapes can emerge. The most common situation is a weaker layer overlying a stronger one. In that case, these craters usually have a terrace on their inner walls where the crater abruptly becomes smaller at the depth where this change in material occurs. In this view, we can see one of these terraced craters. In fact, there are two distinct terraces, implying at least three distinct layers in this target. Images like this help scientists probe the near subsurface of Mars. In this case, the different material strengths are probably caused by layers of ice weak and rock strong. Curiosity Mars rover took this panorama while atop Mount Mercou, a rock formation that offered a view into Gale crater below. Gale crater was formed by the impact of a large meteorite sometime between 3.5 and 3.8 billion years ago. The resultant crater is about 95 miles across and is located just south of the Martian equator.